on. Is this on? Hello? No? Well, let me see about this. Doesn't sound like the mic's on, right? Okay, I'll just have to talk a little bit louder then for right now because we need to get rolling. So, welcome to ECS 50. I'm your instructor, Matthew Butner. We're going to try to blaze through the syllabus today, and then depending on what we need, we'll either try to do a crash course on C, or we'll actually get into the real lecture topics. So the prerequisites for this class are either ECS 40, ECS 36B, or ECS 32B. How many of you guys are here from 32B? Okay, decent chunk of you. My best recommendation to make this class flow a lot easier would actually be to take 34 first before you take ECS 50, because in 34 you're going to cover C and C++, which we're going to be utilizing at both the front end and the last end of the class. So that'll make it a lot easier. We should probably review some C stuff to begin with, but if you decide to stick around in the class, you're going to have to basically teach yourself most of C. I put some links on Canvas for my old course where we did C, so you can go through those or find some website online to help you learn it. I would also recommend stopping a lot by office hours at the beginning to get assistance with topics that you might be struggling with that are related to C, so that you can understand how to do things, or if you need like help on accomplishing certain goals, it'll make your life flow a lot smoother. If you ignore this advice, your life here is going to be terrible, because don't expect to get it all from class because we just don't have enough time. Stop me if I'm going too fast or you have a question, because otherwise I'm just going to keep on ramming through things. So here we're going to learn how to represent data and how data is represented inside the computer. We're going to learn how to program in x86 assembly. Not really because we want to be programming in assembly, because to be honest, it really sucks a lot. But to get a better understanding of how the computer actually works. We're going to learn, though, how to integrate this assembly code into our C and C++ code, and also gain a better understanding of how the hardware and the software in your computer interact, and who's responsible for what, and what does what when. So here's our staff. There's myself, and we have two TAs. One of our TAs is here this morning, Suchita. She has her office hours on Monday, Friday, 2 to 3:30, so stop by there if you need help. I have office hours every day, but they're shared between your course and my other course. But you guys have priority times on Monday, Wednesday, Friday from 12:15 to 1:30, and on Tuesday, Thursday from 12 to 1:15. So today, right after class, we'll be there if you have questions. I'm going to ask when you come to office hours that if I'm not there, because sometimes I get held up answering questions after class, to write like ECS 30, ECS 50 on the whiteboard, and then put your name there as you arrive, and then just a brief topic of what you want to talk about. You could be something like homework 1 or C code, or something like very simple couple words about what you want to discuss. Sound good? So we'll be using CampusWire for our class forum. Most of you should have already been enrolled unless you joined the class very recently. This is how we're going to primarily communicate throughout the quarter with you. Don't expect to see any more posts on CampusWire unless they're super duper important. All questions related to the class should go there, and only private matters should be direct messages to us on there, or given as private messages or private questions, or if you email us. Basically, if there's something that could only ever concern you and you alone and affect no one else in the entire world, those are the things for like the private communication. This just helps us by keeping like questions that might affect a lot of people public, so that we don't have to keep answering them over and over and over and over and over again. So good questions to directly email us about would be like, there's a death in the family, or you got in a car accident, or your house burnt down, something like stopping you from performing in the class. Bad things to ask: how do I get C-Line set up? How do I install a virtual machine? How do I do homework 1? Those are all terrible questions, because probably more than just you have those questions. If you do email us, make sure you include ECS 50 in the title, followed by the subject. I teach 2 classes, so it's always kind of weird, like when you're like, I have questions about homework 1. I'm like, what homework 1? This class or that class? And I have to go look up and see which class you're actually in. So make sure that you let me know which class you're coming from. So here's what you're going to need to get for this class. You're going to need to get a CampusWire account, a course book, a Mimir account, and when you sign up for anything online, make sure that you use your UCD email and your name as it appears on Canvas, because we use that information when we're transferring your grades from those websites back to Canvas because it's not automated. And if you're using like I'm super hot guy at yahoo.com, I have no idea who you are in the class, and your grade's not going to get transferred over. So make sure you use your UCD email and your name as it appears on Canvas. You're also going to need access to a computer running a Linux environment. Again, sign up using UCD email. We'll talk here. It does use Markdown if you want to use Markdown to make sure that your code shows up a lot nicer on there when you ask questions. I also ask that if you have questions related to like some snippet of code, that you actually copy and paste that code there instead of giving me screenshots of it. Because if you give me screenshots and you want me to like say like, hey, what's wrong with this code? I'm like, hey, you need to fix this line. It's really hard with the screenshot because I can't make edits to it easy. But if you copy and paste your code, well, then I can copy and paste your code back and then make the correction to show you what's going wrong. If you are joining late, the course code is 2321. If you are asking questions on CampusWire, I ask that you go through these 3 steps. First, Google your question. It's full of so many answers in case you didn't know that already. And you'll probably find that someone's asked your question there already. It's also really good to get used to using Google because there's a lot of stuff you don't know, and there's a lot of stuff I don't know, and all of it comes down to just finding that information. So the more you practice now, the better you'll be doing it. When you get to your job. If you can't find your answer on Google, search for your question on CampusWire. And then if somebody's answered it, great. You get your answer right away. You don't have to wait for us to reply to you. And then if no one has asked the question, then feel free to ask and we'll get back to you on it. Our book is an electronic PDF. It's written by Professor Matloff, which is another instructor here. There's the link. It's really good. It's actually like one of my favorite books that I read in the class. He does a really good job at writing them. We're also going to be using Mimir. Again, use your UCD email and your name as it appears on Canvas. This is where we're going to be doing your homework assignments and quizzes, or your quizzes might appear on Canvas. I'll let you know how we figure that out in a little bit. This will allow us to give you feedback automatically when you submit your homework assignments, like what test case you're passing, what test cases you're failing. So you essentially know what grade you're going to be getting every time you submit. If you're happy with that grade, great. You'll probably get that grade unless you cheated. If you're unhappy with that grade, keep on working on it, and you will eventually get the grade that you want. It's very possible for everyone to get 100% in the class. I'd be very happy if you all do. It's just a matter of putting in the work to get it. So if you're not happy with your grade, keep putting in more work and you'll be able to raise your grade. I don't curve in the class, so don't expect a curve. If you need a refund, you can get it that way. Any questions so far? Okay, so there are a couple of ways you can get access to the Linux operating system. You can go to the CSIF computers, which are in the basement of Kemper Hall. You can access them either remotely or in person. You can install a virtual machine on your computer, such as VirtualBox, which is what I'll be using in the class. You can also dual boot. You can also use the Mimir IDE as well and program on there, and you'll have access to the Linux environment there. It's not sufficient enough just to have like a Mac, even though they're very closely related when we get to the assembly code, because the assembly code that we write is just a little bit different for Mac than it would be you would write for Linux, and so the code won't run on your Mac machine. So make sure you do have access to that Linux environment. Yeah.
So if we were to just go into the CSIF computers, that would be sufficient for the class?
Yes, if you just go to the CSIF computers, they have everything that you need. There's Canvas. We also have Google Drives. I posted links this morning to be able to access it. You'll see all the lecture slides there, as well as all of the examples that we end up doing in class. For programming in C and C++, I recommend that you use CLion. You're free, though, to use whatever you feel like as your editor of choice when you're programming, but it's free to use. You can get a free student license from JetBrains, and there's a couple of videos I have up online for you to get it set up if you need help with that. So grading homework is worth 40%, quizzes are worth 20%, midterms are worth 20%, and your final is worth 20%. You can also earn up to 2% extra credit in the class just by participating. If you're active on CampusWire, you can get 1% if you reach level 1, and if you reach level 2, you'll get an extra 1% credit. So if you're active and asking questions and helping each other out, free extra credit on the table for you. Homework, it's generally due about every 2 weeks. It's due at 11:55 p.m. of the day specified. I would generally expect homework assignments to take between 10 and 20 hours. If you took 36B with me, it's a lot less in this class. So expect a break. Assignments aren't too complicated. The majority of the time is actually spent in debugging because you'll make mistakes in translating the assembly code. And like every line of C code corresponds to about 4 or 5 lines of assembly code. So there's just a lot of opportunities to make mistakes. And since there are no more variables and there are no more functions, it's just really hard it's just a lot harder to debug, and you have to pay a lot more attention to things that are going on. So be aware of that. On each of the assignments, I'll tell you how long it took me, and hopefully you'll figure out whatever your time multiplier for my time is, how long it's going to take you to do. Any questions so far? Okay, you'll submit your homework on Mimir. You can generally have 10 to 15 submissions. This is just to encourage you to test on your own machine. You should definitely be doing that before you submit. Probably shouldn't be just be like, oh, hey, my code is, I think it's working, submit. Test it out first before you just run the test cases that are available on Mimir. You can work in groups of up to 2. If you're working in a group, you don't get any additional assignments. So let's say there were 10 submissions overall for that assignment, and you joined a group, you wouldn't get 20 submissions for the group. There would be 10 submissions for the group. So if you've already submitted individually 3 times, and your partner's already submitted, maybe say individually 3 times as well, and you join together as a group, it only leaves you with 4 submissions. So they're shared between you. So again, don't waste your submissions. Test on your own machine. I'd also recommend that if you're getting like bugs that are occurring on your own machine but aren't occurring, or bugs that are occurring on Mimir but aren't occurring on your own machine, that you get your code up onto the Mimir IDE and run it there, because it'll be running in the same environment, and so you'll be able to trigger the same bugs there as when you submit for your homework. Don't just be like, hey, it works on my computer and not there, so I should get credit. If you're willing to give me your computer, okay. But you're never going to tell a client, well, it works on my machine. Well, it doesn't work on their machine, right? They're paying you to get this to work. They're paying you for the product, right? So you got to get it working on everybody's machine. And that's because C and C++ unfortunately have things that have undefined behavior, unlike languages like Python and Java. So totally possible to get 100% in the class. Just apply yourself. I guess I should actually change this. Homework is accepted up to 2 days late, and there's a 5% penalty per late date. Should also mention this class doesn't have the academic technology services recording, so I'll try to record the lectures and put them up on YouTube afterwards so that you guys can watch them there if you need to catch up. I'm trying to figure out how to get the YouTube streaming stuff to work consistently, so I'll try to stream it if I ever figure out how to get that to work. And then it will be like uploaded and archived on YouTube for you to watch later. There's a quiz about every 2 weeks. If the quizzes are on Canvas, you'll have 3 attempts per quiz. If the quizzes are on Mimir, you'll have an unlimited number of attempts, because Mimir doesn't support giving you a fixed number of attempts yet. So we'll see how that goes. You need to do your quizzes independently, and your exam questions are very likely to be similar to your quiz questions. So if you got the quizzes down, you should be really good for doing the midterms and finals. There will be 2 midterms. They'll be online. They'll be like quizzes, but bigger and combined. So if we've done quizzes 1, 2, 3, probably expect the midterm to cover quizzes 1, 2, 3. Similar questions, maybe a little bit harder, maybe very similar, maybe a couple new topics for what we have covered in between then. but it shouldn't be too hard. You can definitely come in and ask questions in office hours if you're struggling and get help then as well. There will be a final. It'll also be online, and then they'll probably do like the very last week of finals week to give you the maximum amount of time to submit. Yeah.
Sorry, did you say that the quizzes would be timed?
Quizzes won't be timed. Generally, you'll have like a week to do them, and as long as you get it finished within the week, you'll be good. Cheating, I should just say don't do it. If you are caught cheating, I'm going to give you a 0 on the assignment, and depending on how flagrant your cheating was, I might give you a 0 in the class. So don't do that. It's pretty easy to catch you when you're cheating because there are automated tools that make it very easy to spot code that's similar. So don't do it. Please read the SJA, Code of Academic Conduct 2, because it kind of gives you like a full list of things that are cheating and things that aren't, or things that are cheating. There might be some surprising ones there, like it's actually possible to plagiarize from yourself, which I thought was always really weird, but apparently you can get in trouble for that, so watch out. So here's some examples of cheating. Obviously, plagiarizing or copying code, searching for solutions online. Also, if you're like of the mindset that I'm going to search for a solution online just to see how it's done and I get an idea of how to do it, that's really bad because once you see the solution, you can't unsee the solution. And you probably won't, if you weren't able to come up with something to solve the problem, you now aren't going to be able to come up with something to solve the problem anyway, because you'll be stuck with the solution that you've seen, right? There might also be particular homework assignments where there's really one solution more or less for how to do it, with maybe some tiny variations. So again, if you see the solution, you're not going to be able to come up with anything different. The other thing is there's a big difference from being able to solve a problem versus being able to understand someone's solution. And you've probably recognized that. If someone's like, here's the solution, right? And you're like, oh yeah, that totally makes sense. I got that. That makes sense. Versus figuring out how to derive your solution yourself. It's a completely different process, and you're depriving yourself of a lot of learning if you're searching for those answers online. Looking for or obtaining past exams and homework questions. Hiring someone to do your work. That's definitely happened before in the past. You get a couple $100 for homework assignment. It's kind of weird. But that's happened. Asking someone online, like on something like Stack Overflow, like, hey, how do I solve my homework problem, right? Or some forum, that's definitely cheating. Receiving or providing code from someone outside your group. Receiving or providing assistance on work that's supposed to be completed individually is also cheating. We don't probably have in-class exams, but if we did have in-class exams, you're not allowed to sit next to somebody that you know. This is mainly to protect you. Because if you both have the same weird answer and you're both sitting next to each other, it looks like cheating. But if you're like, hey, we both studied some weird wrong way and we're doing it completely wrong and that's why we had the same weird answer, well, if you were sitting on opposite ends of the class, I'm inclined to believe that, right? But if you're sitting right next to each other, it'd be like, nah, that's cheating. So don't do that. It's also just a good way to protect yourself in other classes as well, not to sit next to your friends. Some things that aren't cheating, you can definitely search for pseudocode algorithms online, just like try to get an idea of like how do things work. That's fine. Discussing high-level concepts with any of the other students in the class, that's perfectly cool. Doing examples that are similar to the homework together, no problem. Asking for like how does a function work, like how does scanf work, how does printf work, how does, those stir copy work. Those functions are completely fine to ask, or asking what some error message means, no problem with that. I'm happy for you guys to collaborate with each other, and I want you to, discuss and interact because a lot of learning happens there. But I don't want you guys to stop learning because of it, or like one person does the answer and then everybody has the answer, because that doesn't help you at all. Yeah.
Amongst groups, is it cheating if one person does all the work in the group, or is that just being a jerky group?
So for groups, I would say that the best way to have a good group experience, because they can be really good, but they can also be really bad, is only form a group with somebody else if they're at the same skill level as you. Because if you're better than them, you'll end up doing all of the work and your partner does nothing. If you're worse than them, they'll do all the work and you'll do nothing and you won't learn anything. So you're paying a lot of money just to come here and sit, which is, probably a waste of it. You also need to be able to meet up on a regular basis. And the only times you guys should be programming is when you're sitting side by side with each other. You shouldn't be doing any independent programming because then someone's not learning something. There may be multiple problems, and if you're like, I'll do problem one, you do problem two, well, concepts in problem one probably aren't covered in problem two, and concepts covered in problem two aren't covered in problem one. So you'll be lacking in a certain area if you're not doing it together. Um, the main benefits from having that partner or for having someone to discuss ideas with, having someone to review your code for potential bugs, for someone to be able to spot errors that might be there or give you possible alternative considerations for how to do something. Basically, having someone to talk to is the best benefit of the partner. And if you're not doing it, it's just not worthwhile. If you do find that you are in a partnership that's not working out, you can totally leave it, right? Even if you're in the same, you say you start the assignment for homework one and you're like, we're gonna be partners, and they're like, halfway through it, you're like, man, you suck and you aren't doing anything. It's okay to leave. I would just say, probably don't leave like the day before it's due, because that's being a huge jerk to them. If you're just like, hey, I actually did all the work and I know we're partners, but you didn't do anything, so bye. If you want to get out early, that's fine. And you can switch different groups between homework assignments. It's also going to be very possible to do all the homework assignments by yourself. So you're not required to work in a group. So only be in one if it's beneficial to you. And as soon as it stops being beneficial, get out of the relationship. Does that answer the question? Any other questions? Yeah.
Does asking someone to help you with a bug count as cheating?
Does asking someone to help you with a bug count as cheating? Definitely not if you ask the TAs or myself. If you're asking somebody else, probably not. But again, you're exposing a lot of code to them, which they may or may not end up copying. Probably the person that you're showing your code to is, you're assuming, farther along than you or already done. And that's why they're able to fix the problem. So I would say probably not getting help on that. We'll be talking about debugging in discussion if you haven't already been there. But you really do want to practice using the debugger and figuring out what your own problems are. Though I will definitely admit there are a lot of nuances and really subtle bugs you can create in C and C++ because of pointers and memory. Anything else? So if you want to succeed in this class, oh, that one's for the other course. You can definitely take 4 classes if you're doing this one. Just start early on your homework assignments. As soon as you get them, just read them. The homework assignments for homework 1 are posted. You're not able to do them yet. So if you're like, I have no idea how to do this, that's fine. But at least read through them, get thinking about them, have them on your mind, just so that they can be there on the back burner and you can kind of like be evaluating what you want to do. Like you're washing dishes, be thinking about it, right? You're cooking dinner, be thinking about it. Bike ride home, thinking about it, right? Just have it on your mind, because if you're able to spend that downtime thinking on it, like when you're not really doing anything else, it'll save you, time later on. Also, starting early gives you time to take breaks, which is really necessary to be successful, because there may be times where you just need to like step away from the computer instead of trying to keep punching holes through the wall, right? There can be points where you're just blocked and you just need a good night's sleep to get past it. And if you start early, you have the time for that. You might also find that you get breakthroughs just when you step away from the code, right? On that bike ride home, in the shower, while you're washing dishes, whatever you're doing, something else. Sometimes the inspiration comes to you then, not when you're just staring really, really, really hard at the code, because again, you kind of reach that deadlock. It also gives you time to come to office hours, ask questions, and get help. I would also recommend for office hours, when you come early as possible. Discuss the high-level ideas, discuss the concepts, discuss your plans with us. Because if you're discussing those things and you're going down a bad route, then we'll probably be able to prevent you from doing that and wasting tons of time there, right? Or we might be able to ask you to consider other things based on your solution that you may not have already considered that might change how you end up doing things. And the earlier you come to office hours, the better it's going to be for you. Just interact with us, ask questions in class, ask questions to each other, ask questions on the class forum. interact because a lot of learning goes on there. Just be proactive with everything. And if you ever start to do worse than you would like to do in this class, get a hold of us immediately. Come to extra office hours. Start doing something to make a change. A lot of us can be really stubborn when things start to go wrong, and then you'd be like, it's just a one-off thing, right? It's not really going to matter, right? I'll be able to pick myself up and just push harder and be able to get through it. But if there's something that's prevented you from doing well in the previous homework assignment, those topics tend to compound on top of each other, and they're used in the next homework assignment and on the next homework assignment. So if you're weak and you're struggling on something, you're probably going to continue to be weak, and that's going to keep affecting you on every homework assignment, probably making you do worse and worse and worse and worse. And even you're like, well, I'll just spend extra time learning that thing by my own, on myself, right? Odds are you probably won't, but even if you do, there's something that's still blocking you from doing it. So you probably need an additional person. And so getting that help will save you a lot in the long run. And the earlier you come to us letting us know that you need help, the more that we can do for you. If you come to us like at the end of the quarter and you be like, hey, I'm failing your class, what can I do? Take it again next quarter, I guess, right? Because I can't do anything at that point. But if you're like struggling in the middle of a homework assignment, we can help you figure out why you're struggling on that and help you improve before it's due, right? Or again, the earlier you come, the more we can help you out, the more we can do for you. And I really do want to see you succeed, but a lot of that burden for just seeking the help lies on you, and I'd rather not see you go into like some death spiral with your grade. Sound good? Any questions before we start talking about C? Okay, so let's talk about C a little bit. And probably not enough for you to be proficient at it. But again, if you're seeing something that's, what the hell is that? This doesn't make any sense. Just stop me and ask questions. The smart students are the students that ask questions in the class, right? Because then they're able to continue learning, right? If you don't ask questions, you don't learn, because questions are like your best commodity. They're the thing that enables you to learn, right? If you think about all of science and how it's done, asking questions is how we ended up getting to answers. Why did the apple fall? Why did the apple fall with this rate? What is this thing composed of, right? The questions are what lead you to your answers. So you got to ask questions. In the back. Sure, absolutely. This one? Anything else? Yeah. The codes and lecture slides will be posted online, and they're already there. Again, that class Google Drive, it'll get updated as soon as I make changes, which is why I use it. Anything else? So I guess we should switch to C. I want a C executable. So C is a statically compiled language, which means it takes a compiler to run through your source code to then produce an executable, which is then run. This is in contrast to something like Python, which is an interpreted language, which as the interpreter reads through your code, it starts executing it. So one of the first things that I recommend to you is to turn on warnings. So over here in my cmakelist.txt, I'm going to wait for it to add some warnings. Oops. So first you're going to list the name of your executable. Right now my name is Crash Course, C Crash Course. Private, you'll want turn on all warnings, turn on the extra warnings, and then treat warnings as errors. Warnings are things that aren't syntactically invalid in C, but probably signify that you've made a mistake. So you should definitely treat them as errors because they're probably wrong. An error is something that prevents the compiler from compiling. An example of this from real life would be, you can tell your girlfriend, I hate you, right? That's totally semantically correct, but probably going to lead to a lot of bad things happening in your relationship, right? Versus you can't say something syntactically incorrect in English and have it make sense, like dog green blue, yeah? Doesn't make sense, right? So there's a difference. So over here in main, there's int argc char double star. Why are you complaining about this? Okay, it's complaining because I haven't used it yet, so maybe we'll comment that out. So comments can be written in two different ways. One is, well, I guess you're not going to like that, are you? We'll just comment it all out for right now. Comments can be written one of two ways, /star, and then everything up until that line, the closing star clash is a comment. So multi-line comment. And then single line comment, starts with 2 slashes. C kind of goes with a philosophy that you should only pay for what you use, so a lot of stuff isn't built in. For example, printing is not built in like it is in Python. The print function is actually contained inside stio.h. So if you want to be able to use that function that's in that library, you have to include it. So pound include stio.h right here. What pound include really does, it just means copy and paste. So it's going to copy and paste everything from stio.h into this file, which try to hopefully talk about header files if we have time. So here you can see our print statement. It says print hello world. Strings are enclosed in double quotes in C. You can't use single quotes for a string. So have to use the doubles. And then the return 0 has to correspond to our return value over here in main. And it says I will return 0. When you return 0 from main, it means you successfully completed. If you return anything besides 0, it means something went wrong with the program. It's program specific.
Question.
Yeah.
Can you set it so that like a certain thing goes wrong, it returns 1, and then you like how do you know what this return? Oh, it says customer exit code.
Yeah. Yeah, and then like generally the return code would be utilized by other programs if they were running your program to see if it's successfully completed. Any questions so far? So you can see in C++, since we're statically typed, once you declare a variable, you have to declare it with its type, and once you declare it to be of that type, its type cannot change. So your basic types are integers for integral numbers. So integer number equals 35. Number is equal to 35. We also have characters. So letter, they're enclosed inside single quotes. B, doubles are for real numbers. So 35.27. Now over here, if we want to print out some values, it's printf. And then we use a format string to specify how we want things to be printed. So you might say number is %d is for integers. And then we put number here to be the value that should be printed out. Then you might say printf letter is %c and real number is %lf. So over here we have a letter and then real number. So you can do multiple variables printed out in a single line. You just have to have enough placeholders for them. So the number of placeholders that you have in your format string need to be equal to the number of things you want to be displayed. If there's a mismatch, your program's probably going to have some comments, or probably going to have some problems. And then I should also say that every statement needs to end with a semicolon. For those of you that come from Python, this will probably be the biggest mistake. When I first learned C, I forgot a semicolon on the end of every single line that I wrote in my first program. Every single one of them. We're all missing it. So just remember to go put it back in there. And if you run it, you'll see the values get printed out. Yeah.
So the percent, and then it's a placeholder, and then it just does it in that order of like what you add.
Yeah, it's in the order, so I can't do real number first, then letter. So they get filled in the order that you go through them.
You can put whatever you want after the percent sign.
So no, the placeholders are specific. Percent D stands for decimal number. Percent C is for a character. Percent LF is a long float, which is double. Yeah.
What do you do for a string?
So if you want to do a string, strings are a lot more complicated in C. But if you want just a basic string, the way that you declare it is as an array of characters. So we might have char stir equals hi class. So over here in the square brackets, you put the size of how many characters space you want to make available. But because I'm signing it directly to a string constant, I can leave that out, and the compiler will figure out how many characters are here. So here it's going to make space for 1, 2, 3, 4, 5, 6, 7, 8, 9 characters actually. Because the way that the string is represented is actually as an array of characters, so I'll make a shorter one. So stir2 is equal to single character, hi, null character. So a string in C is an array of characters that ends with the null character. That null character is the /0. Does that make sense? So one of the biggest mistakes that people make when working with C strings is to forget to put the null character on the end. By default, when you write a string literal like we're doing right here, it automatically has the null character. But if you're like dynamically creating a string or forming it from other strings, make sure your strings always end with a null character. Yeah.
Just going back to the percent sign, when you said that the types are fixed, that means you try to put like use the percent for a decimal, but then you put like the integer type, will that be an error, or will it just add?
So the percent %d for decimal is for the integral numbers. So you do want to do percent %d with integers. Maybe your question might be like, what happens if I do percent %d, but I put in a float or put in a double there, right?
Yeah, if the types don't match, will it change it to a different type, or does it have to?
So if the types don't match, you're going to get some funny output. And it's actually going to cause the compiler to display it differently. So if we go ahead and try this, so printf, this is a string. Strings are %s. And then you can say, stir. And so is %s. Stir2. So if we try doing something, interesting, like let's say we make this something like 72. So printf a number as a character is %c, and then we throw a number here, and then we go ahead and we run this code. I forgot to put a slash in there, but you can see that number as a character, if you interpret it that way, is actually considered to be equal to the character h. So this has to do with something we'll cover later on. It's just that they had the same bit patterns. So that's why it's showing h. Yeah? The null character does count as part of the size of the array. So if we have something like the string that contains cat, C-A-T, we actually need 4 characters worth of space to be able to hold that. The C, the A, the T, and the null character. Any other questions? Okay, so these arrays that I've showed you right now, they are statically allocated arrays, which means their size cannot change. So in Python, you're used to being able to add elements to a list and remove elements from a list, or like change the list size. You can't change it. This string over here, this is an array of 3 characters. It will always be an array of 3 characters. It will never be an array of more than 3 characters. So its size is fixed at compile time, right? It cannot be made bigger or smaller. Some other things that we might want to see are how to make some functions. So functions are pretty easy. It's return type, function name, arg1 type, arg1 name, arg2 type, arg2 name. You keep on going until you have enough arguments to get your life done. And then we close it up, curly brackets, and then we have the function's body. So sound good? So let's say we wanted to write a program that could calculate the areas of shapes like squares, rectangles, and trapezoids. So I'm going to make 2 new files over here. So create a new C++ source file. We want a C file. C files end in .c. I would like an associated header with this, and I'll show you why in a moment. And then here we might just call this like areas. Functions, just like in Python, can either return 1 or 0 things. You can't return multiple things from a function. So over here, if you think about a trapezoid, if you think about it, this trapezoid, right, it's made up of 2 triangles, right, and a rectangle. Make sense? So we're going to write our function that way when we do the area for the trapezoid. So first, though, we might start for like area of a rectangle. So the first thing should be, get rect area. What should my return type be? You pretty much have like 3 choices. Do you want it to be an integer, a character, or a double? Double, right? Should be a real number. What parameters do we need to be able to figure out the area of a rectangle? Double width, right? Like double height. So then how do we compute the area of the rectangle? Right, it's just width times height. Again, you can have longer function bodies than this, and this is the value that we're going to get back from the function. Indentation doesn't mean anything in C or C++. It just makes reading things a lot easier. So still use your good Python indentation, even though it has no effect on the C code. Now, how might we define the area of a triangle? What do you need? The base and height. If you think about it, a triangle is blank a rectangle. Half, right? So we could just say return get rect area, right? Pass in base and height, and then divide by 2. In C, there is no double divide operator. There's also no exponential operator like there is in Python. The type of the division that's done is based on the type of the variables that are involved. Double And like, so double arithmetic anything is always going to give you back a double at the end of the day. But if you do integer arithmetic integer, you're going to get another integer. So some interesting results from that are, we might say printf something like 3 divided by 4 is equal to %d. 3 divided by 4. So what do we expect our answer to be here? With 3 divided by 4? It's 0. Because the numbers are all integer numbers. So we get 0. Right? If we wanted to do double division, we got to make sure our numbers that are involved in the operation are doubles, and then change our type over here. So you get 0.75 like you were expecting. Or again, if we have 3 divided by 4, 4.0, again, double integer goes into the double realm of arithmetic. Or double integer, again, we're going to be in the double realm of arithmetic. So anything involving doubles puts you into a double, right? But you can also do some things like this. We might have int, x is equal to 3.0 divided by 4.0. And then printf %x is equal to, what should my format specifier here be? Percent what? So C S D LF. Okay, let's try. So if we look over here, compiler is not happy with it because X's type is integer, right? So we need to be displaying a integer, right? I can make it stop complaining, and it'll let me do this. So if I get rid of treating the warnings as errors, it'll let me do it. But again, I don't recommend that you remove this flag. And again, now we're attempting to interpret that integer's bits as a double, which can cause some really weird things, but it just so happens that the representations for 0 are the same in both, so we get 0. So we put this back in so we don't make mistakes. And return this back to %d, and again, we're going to get x is equal to %d. And we'll get 0. The reason for this is because the type of this expression, it is double, but it's going to be stored into a integer. So in this conversion, the compiler will implicitly convert the value of the expression on the right-hand side to the type of the variable on the left-hand side. So we'll end up converting our float into an integer and then storing that result in our integer x. So we will get 0.75, but 0.75 converted into an integer is 0. So we end up with 0 here. Yeah.
On line 26, when you say it's like %LF, and then you say like 3.0, what if you just say 3 over 4?
So 3 over 4, they're both integers, so you'll end up with a integer.
You place it as a load?
So when you do the 3 divided by 4, if they were both integers, you end up with 0. So it just so happens that a double's representation of 0 and an integer's representation of 0 are the same. So you would see 0.0 printed out. But again, generally the types here aren't quite right. So as long as they have the W error option turned on, it won't let me compile. Treat the warnings as errors because it's like saying like, hey, you're doing something weird that you probably didn't intend to do, right? watch out for this. But I said, okay, make anything that might be a mistake an error so that I can't compile, so I have to address it correctly. Okay, so we have the area of our triangle. Now let's say we want to get the area of our trapezoid. Are there any other questions? Okay, and so what do we need for the trapezoid to be able to figure out its area? We need the height, we need the base, but we also need the length of the short side, right? So we need the length of the short side, length of the long side, as well as its height to be able to figure out everything. So double long side, double short side, double height. So again, we said that our trapezoid, right, it's made up of a rectangle as well as two triangles. So how much is our rectangle? How big is it? What are the dimensions of our rectangle?
Short side times height?
Yeah, they're going to be short side long and it'll be height tall. So you might say something like double rect area equals get rect area. And then here we might say we want to pass in short side and height. So here you're running into one of the nuances of C, which C is what's called a top-down one-pass compiler. So that means when it runs through your code, it starts at the top of your code, it goes to the bottom of your code, top down, and it goes through it once. Because of this design, C has to know about things before you use them. So here, when we get to this line where we call get rect area, if we start from the top and we work our way down, have you seen get rect area before? No, compiler hasn't either. So it's like, what the heck is this? I don't know how to do this. Is this right? Is this wrong? So in order to resolve this problem, there are two solutions. Solution number one is we take this function and we put it below this function. Because when you get to that point, you'll have already known that's defined. This probably doesn't sound like an ideal solution because there might be a lot of dependencies on your code, right? And it's really restrictive to have to write your code in a certain order. So probably don't want to go with that. So these guys here are called function definitions because they can tell the compiler what to do. There's also something called a declaration. So this is a definition. And also a definition of the function because they can tell the compiler what to do. If you just want to tell the compiler something that exists, you give it something called a declaration. A declaration is everything that's the function is made up of except for its body. So if I want to say that, hey, compiler, this function exists, I say it exists. And that's it. The compiler doesn't know enough to how to run it at this point, but it's going to be like, okay, this exists. I'm fine with it. I know what arguments it takes. I know what its name is. I know what it's going to return. So I know how to use it. And you're also going to promise me that later on you will provide a definition. So right now when it sees get rect area, it's like, oh, get rect area is something that's going to exist, and it looks like this. So when you go to use it, you're like, hey, I'm using it correctly, right? I gave it 2 doubles. I got back a double. Everything looks fine here, even though I'm not quite sure what code I should run. And as we go down in time, it's like, get rect area. Okay, this is what I should do. So now I know what I should do when I call this function. I know what its definition is. Yeah? It doesn't run a second time. So the declaration just tells the compiler this thing exists. So I'm not running this code. I'm just saying, hey, compiler, there's a function called get rect area. It takes 2 doubles and returns a double. The end, right? And given a declaration, the compiler has enough information to know how to call the function, but it doesn't have enough information to be able to actually run the function because it hasn't seen the definition yet. Any other questions here? One other thing that I left off of is in C++, all of your code has to be inside of functions. You can't just write arbitrary, for the most part, pieces of code outside of functions. It all has to be inside a function. The function that your program begins at is main, and there can only be a single main function per program. Sound good? There can only be one main, just like in Highlander. There can be only one. That's where your program always starts. The reason that there can only be one is because if there was two mains, the compiler wouldn't know where your code should actually begin. And essentially, all your code has to go inside of functions. Some exceptions you can see of things that don't have to go inside of functions are the includes. Declarations don't have to. And then obviously, like the outside of your definition doesn't go inside of a function body. So one recommendation that I have to you when you're writing your programs is that you put all the declarations at the top of your code. So we're also going to put a declaration for a trap area. As well as for try area at the top of my program. Oops, not here. Top of my file. So now the compiler knows about all of them, so I can call them in any order that I feel like, which is probably a nice convenience and definitely worth a little bit of effort to put it there at the top of the program. Any questions so far? Yeah.
I know in C++ there was like an automatic thing where you could put it in an H file.
We're going to get to the header files in a moment. So we got our rectangle area. Our triangle area is get try area. So how wide is our base going to be for our trap, or for this little triangle? It's going to be the long side minus the short side, but then it's split among two triangles, so divide by 2. So our base is long side minus short side, parentheses, I need extra parentheses here, divided by 2.0, just to make sure that we always do that double division. And then our height is just going to be height. So now we got the area of a triangle. So our total area is the area of the rectangle plus 2 times the 2.0 times the triangle area, because we have 2 triangles. Does this make sense? Any questions? Okay, so now let's say back here in main, we create another function. If your function doesn't return anything, its return type is void. So void run trap area. So what we might do is this little function might ask the user for some numbers. We'll read them in, call the function, life will go on. The function for reading input is called scanf, but I'll show you that in 1 second. So one thing you can also do is you can declare multiple variables on the same line by putting commas between them. So here we might have something like long side, short side, and then height. Notice that I haven't given them any values. This is perfectly fine in C and also in C++, because the compiler knows the type of the variable, so it knows how big to make it. But when you declare a variable this way, since I didn't give it an initial value, its value is undefined. What undefined means is I don't know. It's whatever the compiler happened to put here, which could be anything. So one of the key things that you have to make sure when you're working with your programs is that every variable is at least initialized before use, because if it's uninitialized, you're going to get some weird behavior, which you might try printing them out right now. So printf, %lf, 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 and then put in long side, short side, and height. Now the compiler is going to complain at me, which it should rightfully do. These variables were not initialized yet, right? Which is something that the compiler will definitely cause probably some weird issues later on. So over here, I'll take this off just to show you it happened, where the compiler will still warn me, but it'll let me do it, right? Again, this is like, the compiler will now let you tell you that you hate your girlfriend, which is probably not the best idea. So we're going to call run trat area, which probably is not the best name. So I'll show you a cool thing inside of CLion. If you click a variable or function name, you can right click on it, say refactor, say, where is it, rename, and then you can rename this variable, which is I wanted to rename it run trap area, and it will also go change it in every place that's relevant. So I don't have to go to every single one manually and change it and probably forget to change some. It only changed that one. It also works in specific contexts. So like if I decided to rename long side over here to be something else, like L side, it's not going to go change the one outside of this function, only the one inside this function. So it's a lot smarter than just find replace. Yeah.
When you refactor it, will it change it in other files as well?
If it we'll see in a moment that if I start using that function from another file, and because that is that one that I'm trying to rename, yes, it would rename the ones in the other files too. But like, I guess I'm saying if I have something like x here, and I have an int x here, and I say something like printf, again like x equals %d x, comma. If I decide to rename this variable x, it's not going to rename this variable down here. So like if I decide to rename this guy, which the shortcut on my computer is Shift F6, if I rename it to y, rename code uses, it'll change only this one. It's smart about it. It's only really changing that variable that we're actually talking about. So here it happens that my compiler decided to make those variables be equal to 0, but other compilers might just leave them as random garbage. This is really comes back to bite you if you forget to initialize the index for a loop variable, and now you're going through your array indexing it at I. So if you say like int I, and you say like for I, then you do your whole for loop for int I less than the length of your array plus I, So if I forget this causes a lot of undefined behavior. My computer might decide to make I be equal to 0. And on my computer, it runs, and I'm happy. I then go submit on Mimir. The Mimir compiler decides to leave it as random garbage because you didn't say what it should be, right? And the C standards don't say what it should be. You then, maybe it says it to 500,000. The code then runs. Well, my array only has 3 elements, so I go to access element 500,000 and I get a segmentation fault and my code breaks. And that's how you get those behaviors where code works on one machine, but not another because of these undefined rules for compiler behavior that aren't specified by the C standards. Does this make sense? Any questions? You'll probably want to go back and rewatch today's lecture, would be my guess. So anyway, over here, you might ask the user to enter some values. So printf, enter the length of the long side. Now to read variables, it's scanf, to read from user input. Again, you give a format string. So the type of the thing that I'm trying to read is a, say that again? LF, right? Because I'm trying to read an integer or a real number. But I don't just say long side here. what the scanf wants is it wants the address of that variable to put it into. So we put an ampersand. The ampersand is the address of operator. It says, give me the address of this variable. Where in memory does it live at? And then scanf will go to that location of memory and put the value in there. Let's go make sure we make less errors. So turn that back on. And then we might say something like enter the length of the short side. And then we put this into short side. And then we might say enter the height. And then we're going to put it into height. So again, scanf wants addresses. Give me the address of the variable that you want to put the value into. Again, we'll probably talk about memory and addresses a lot more Thursday. So now we might have our new variable, double trap area is equal to get trap area. And then we'll pass in the, what did we say we wanted to pass in? Long side, short side height. Again, you can see that the compiler is unhappy because it has no idea what trap area is, right? Because if we look through this file, have you seen any mention of it? No. So in order to resolve this problem, there's something called header files. So in the header files, which are our .h files right here, we're going to put our function declarations in the header files. You put the definitions in the C files, the source files. So declarations in the .h. And you'll put your definitions in the .cpp, or the .c, the source file. So we'll move these guys over to here. And you want to put them inside this little structure that we have over here. This is called the header guard. And it basically prevents circular inclusions. Because I said earlier, an include is just copy and paste. And so if you keep copying and pasting the code in a cycle, like A includes B and B includes A, then they'll infinitely copy each other forever. But what this says is it tells the compiler, if this symbol has not been defined, so if crash course areas underscore h has not been defined, define the symbol crash course areas underscore h. If the symbol, however, is already defined, the compiler will skip this entire section of code to the matching endif. So if the symbol is defined, this condition won't hold true. We skip the code. If this condition, so I should say, if the condition does not hold true, yeah, we skip the code. If the condition does hold true, we haven't defined the symbol before, we will run the code and we will put the declarations over here. So now, if we look back at areas.c, we're going to see that again, our complaints went away because in areas.c we included areas.h. Again, copy and paste. So we copy and pasted this code to the top of our file. And so it now knows about all of these declarations of these functions. So it knows how they should be called and what their signature should be. So if I want to be able to use them in another file, I just have to include it in that file. So pound include areas.h. So you can see here from these two lines of code that system files, you enclose them in triangular brackets. User-defined files you include in quotation marks. System files, triangular brackets. Double quotation marks are going to be for user-defined files. Yeah?
So how do you change the name, change the file name? Because I couldn't really tell the first file is area.h or not because the word is too small or something.
So how do I change the name of my files? Or like how do I know which one is which?
So I want to know how do I change name of my files, and I also want to know is the first file called area.h.
So this file right here is areas.c. This file is areas.h. If you want to change the name of the file inside of CLion, you just right-click on the file name. Come on, pop up. And then say refactor, rename, and then change it. If you're just working in your file browser, you just change its name, and its name will then be changed. Any other questions? Yeah.
When you refactor it, will it also kind of do the smart refactoring where it changes your like definitions or your inclusion?
Oh, so like let's say I'm over here in main, right? And over here I have get trap area. Let's say I change its name to be get trap area really.
I meant for the file name.
So if I change the name of the file and I use the refactoring, it will change all of the includes. And it should also, I believe, I can't quite remember, change the name of the header guard. Because it's important that each header guard be unique. Because if they are not unique, then you'll see the symbol is already defined. And then you won't run the code that you intended to run. This is why, in general, the names of the headers, the header guards, the symbols here, are like the names of the files because the files have to be unique. Any other questions? Yeah.
Can we use pragma once?
Question is, can we use pragma once? Pragma once isn't supported everywhere, but if it works on Mimir, I'm okay with you doing it. This is just the more generalized version of pragma once. Any other questions? So then finally out here you might say printf the area of the trapezoid is %lf/n. So one thing that you can do here is you can say something like %.2. So you can do like point something that says display at most, or display always 2 decimal places, instead of allowing the compiler to choose how many things should be displayed. And then I would like to display trap area. So then down here, we're going to go ahead and run trap area. So now it's going to ask me to enter the length of the long side. Maybe it's 10. Enter the length of the short side. Maybe it's 2.43. Enter the height. It's 3.2154. And the area of my trapezoid is 19.98, which is, amazing and everything. But again, you can see the decimal points are limited to be 2. Even if I do something where there shouldn't be decimal points, I don't know. 10, 10, 10. It'll still display the decimal points because I said %.2. Any questions before we continue to bulldoze our way through the C syntax? Yeah.
How is the cMakeList.txt related to our main?
So the cMakeList.txt, they are commands to a program called cmake, which tells you how the program should be built. So over here, I'm saying the minimum version of cmake that I require is version 3.15. The name of my project is Crash Course, or C Crash Course, and it's going to be written in C. My standard that I'm going to be running with is the C 2011 standards. Here I'm saying create an executable. Its name is Crash Course, and I'm going to create it from the following files: main.c, areas.c, and areas.h. I'm also telling the that I would like, when I compile my program, I would also like to add in these extra flags right here to the compiler. So if I was building this from the command line, which you totally can do, so here you can see that there are my files, right? So the compiler, its name is GCC. -G turns on the symbol, it remains retain the symbol tables. This will allow you to debug your code later on. -wall, -w error, -w extra, right? All the flags that we had before. -o, the name of the executable that I want to create. Maybe I want to create my executable as Bob. whatever. It can be, name your executable something sensible, but I'm going to call mine Bob. And then you would list the names of the C files only, not the H files, only the C files. So main.c, areas.c. And then if I list again, here's my executable bob.out. And if then I then type ./bob.out, it's going to go run it. Exact program that we have here. So 3, 4, 5. There's our area. The CMake, though, makes things a lot more convenient, I think, especially as the projects grow in size. We won't be doing like really any big projects in this class. So if you're using CLine, the CMake file that it generates for you, only fine. Any other questions? Oh man, I still got 13 minutes. Where are you going? No, wait. No, we end on the hour, right? No. Wait, what time do we end? We end at 12, right? 11:50. So yeah, 10 before. So I got 3 more minutes. I'm totally going to use all of them. Okay. So some things you probably want to see are loops. How the heck do I do that? So we'll make a new C++ file to kind of loops. So there are 2 types of loops in C. There's a while loop and a for loop, but essentially there's really only one type of loop. So here we might have something like void, a while loop. There's actually 3 types of loops. I forgot to do while. So here, there are no element-based loops in C, so we have to declare a variable to do our indexing. So you might say like int index is equal to 0, and then it's while parentheses are required. Say I is less than num iters, or I called it index, is less than the number of iterations. You then do curly brackets and then code that you want to run. So maybe I want to print something, so I'll pound include stdio.h. No, it's CS. Oh gosh, it changed. Oh gosh, I'm so used to being Python. No wait, it's stdio.h. Anyway, we'll let it stop complaining. Ignore that for right now. So then we might say printf %d. Oh. Did I forget to add it to my CMake list? Is that why it's complaining? Anyway, so you might say printf %d/n index, and then we have to make sure that we do ++ index. ++ index is basically equivalent to index plus equals 1. So just add 1 to the index, and we'll print things out. Oh, it's because I changed it to a C++ file. Refactor, rename. Okay. I'll see you guys in office hours if you have questions. Stop by if you don't understand C. Also, make sure you do a lot of reading about C in your own free time to be prepped for the class.